डिले मेरा। रुक जा, चेक कर लेता हूँ भाई। कोई डिले डुले नहीं है मेरा। बढ़िया, सही चल रहा है एकदम मक्खन। हेलो। हाँ, मुझे 40 तो आ रही है सर। 40 आ रही है ना? चलो, तो पीपीटी वाले पार्ट पे जाता हूँ। हम्म। इमेज आ रही है क्या टेबल इसकी? हाँ, अब बोल, क्या बोल रहे हैं? डिले तो है यार थोड़ा बहुत। अच्छा।
आशीष एक बार स्टार्ट करूंगा बिल्कुल बेसिक से।
ओके। हेलो एवरीवन, गुड मॉर्निंग टू ऑल। कैसे हैं आप लोग? So yes, today we'll talk about the kinematics, and definitely this session is almost the neat target, right? So we are just targeting the exam जो कि अभी होने वाला है in August 2021. It's said to be held in August, but अभी देखते हैं ना, कुछ पक्का नहीं है. But yes, we हम अपनी तरफ से तैयारी पूरी रखेंगे. For that I must say कि हम फोकस करेंगे. We are focusing basically on the questioning part and the formulas part. Okay. We are not going on this derivation part क्योंकि नीट एग्जाम में डेरिवेशन से कोई रिलेशन नहीं है. एंड फॉर दैट आई मस्ट से जस्ट key points जो important होंगे, we are only focusing on those key points. Okay. So the very first thing about the kinematics, if we talk, so we have 5 parameters: distance, displacement, speed, velocity, and acceleration. Okay. So about the distance and displacement, we all know this. What is distance? Distance is actually nothing but what the actual path traveled by an object. And what about the displacement? Displacement is nothing but the shortest distance between the initial and the final position, right? Okay. So here in the animation, as you can see, a person, if it starts from this 0 and move to this 6 and came back to the original position, or you can say came back to this 2. So how much is the distance? Firstly, it covers the distance of 6 meter. Then it came back to this. It covers a distance of 2 meter, right? So in case of distance, the total distance comes out to be of 8 meters, right? But instead of this, if we talk about the displacement, so in case of displacement, what is happening? The person starts from 0, it goes to this 6, so its displacement is 6 meter. But when it came back to this 4, or you can say when it came back to this 2, it covers a displacement of yeah, it's of 4 meter. Okay. Yes. So in the both cases you can see this distance is a scalar quantity, so we are just directly adding them. But in case of displacement, we are just using the sign also. Okay, so the displacement is a vector quantity, so we have to use sign convention. For the positive side we consider it as a 6 plus 6, but for the negative side we consider it as a minus of 4. So the total displacement comes out to be 6 minus 4, which will be of 2 meter. Or you can say that the displacement is nothing but the shortest distance between the initial and the final position. See, this will be your initial position, this will be your final position. So the distance between the initial and the final gives you displacement. It again comes out to be of 2 meter. Okay. So all about the displacement and the distance is nothing but, yes, we have distance as a scalar quantity while the displacement is having a vector quantity, both having the same unit, same dimension. If we talk about the magnitude, so that definitely the magnitude of the displacement is something lesser than this of distance. And for this I have this animation, as you can see here in this animation. If an object starts from this point A, okay, and it goes to this B, then C, then D, E, F, and G, H, right? So the final position comes out to be H. The initial position is A and the final position comes out to be H. So in that case, what is happening? The total distance covered is 10, 10, 10, 10, 15, 10 and 5. It comes out to be 70, but the total displacement is, you can see, 14 kilometer only, the shortest distance. So definitely the magnitude of the displacement is always, I'm not saying that it is always, but yes, it's lesser than or equal to the distance. But in which case it is equal to the distance? In which case the displacement is equal to distance. This is possible only and only when the object moves along a straight line. So for that I must say, okay, so yes, when it moves along a straight line, so this will be your initial position, this will be your final position. Suppose it moves 5 meter, okay, so your distance comes out to be 5 meter. Also we know that displacement is the shortest distance between the initial and the final position. So for that I must say that the A is the initial position, B is the final position, and their distance, shortest distance between them is again of 5 meter. So yes, your distance and displacement both are equal. Only and only in the case when the particle moves along a straight line. So this is the thing, okay? So only and only when the particle moves along a straight line, then only its distance is equal to the displacement. So this is all about the distance and the displacement. Now let's solve a question based on Vishal. Vishal, actually getting some problem. It's not showing the live chats.
Okay, I just commented from my side.
No, I'm not getting your live chats actually. And it's also showing. No, I'm not getting your chat. Vishal, I'm not getting your chat here.
Okay, you're not getting my chat. I think the chat on.
I don't know, and all. Okay, okay, so it's, yeah, it's private. See, let me show you the interface of my phone. It will be something like this. Here in this part, I'll have the chat section. Okay. So जो भी chat मुझे दिखेगा वो यहीं पे दिखेगा, नीचे की तरफ पूरे एक डिस्प्ले चलता रहता है चैट का. So in my phone I can see the chat.
This is how it looks. Maybe it's showing something on the screen. Yes, yes. आशीष क्या चालू कर दो 5 मिनट के लिए और फिर देखते हैं देखेंगे.
Sure,
तो
sure.
शाम को फिर पब्लिक करेंगे. कोई दिक्कत नहीं है.
Okay, fine. So let's see the question based on this. A runner completes one round of a circular path of radius r in 40 seconds. His displacement after 2 minutes and 20 seconds will be. So here in this question, as you can see, we have a runner and it completes a one round of a circular path. So we have this circular path, okay, having some radius r, and now it is said that a runner is completing this whole circle in just 40 seconds. So suppose this is my initial position, and if the runner starts from A and ends at A, so the total time taken by the runner is of 40 seconds. Also, we know this here, the initial and the final position are same. So I must say the displacement will be 0 in this case. Is it so? Yes. If you start from the point and end at the same point, in that case, the displacement of the object will be 0. So in 40 seconds, the displacement will be 0. How much will be the displacement after 2 minutes and 20 seconds? So if I talk about the 2 minutes and 20 seconds, so let me solve this. 2 minutes and 20 seconds, converting it to the seconds, so it can be written as 2 into 60, converting minute into 60 plus 20. So once you solve this part, you will get this 120 plus 20. Okay, so after solving this part, we'll get this value 140 seconds. So the value of t comes out to be 140. Now I know the thing that at 40 seconds displacement will be 0. So if I break this 140 into 40, 40, 40 and 20. See, 40 plus 40 plus 40, it comes out to be 120, plus 20 comes out to be 140. So in the first 40 seconds, you complete first round. In the second 40 seconds, you will complete your second round. In the third 40 seconds, you will complete your third round. And in the next 20 seconds, you will complete the third and half round, right? We are just completing the half round in this. So it's something like I started from A and ends at point B. So in the 20 seconds, I started from the A and end at the B. In that case, if I wish to find the displacement, so displacement is the shortest distance between the initial and the final position, and that will be equal to 2r. So here in this case, the displacement comes out to be 2r, which is in your C option, and yes, this is the final answer. Okay. Now let's move on to the next part, to the next question. It said that a drunkard walking in a narrow lane takes the 5 steps forward and the 3 steps backward, followed again by 5 steps forward and the 3 steps backward. Okay, and so on. Each step is of 1 meter long and requires the 1 second to cover. How long the drunkard takes to fall in a pit which is 13 meters away from the start. So here in this question, it is said that we have a person, okay, and this person is actually drunkard, right? So it's moving 5 steps forward, then 3 steps backward. Okay, so this drunkard is moving something like it's moving 5 steps forward and 3 steps backward. So each step covers 1 meter. Okay, and time taken to complete this whole part, like each step is of 1 meter long and required 1 second to cover. So one step takes 1 second to cover, right? Okay, so if we talk about this drunkard, so what will be the displacement of this drunkard? So if it is moving 5 meters forward and then 3 meters backward, so the displacement of the drunkard is of 2 meters. Okay, and in this 2 meter, how much time it is taking? 5 seconds for the forward and 3 seconds for the backward. But we know that time is a scalar quantity. Therefore, we have to add this time. So it will take 5 plus 3, 8 seconds for this complete motion. Okay. Then it again moves forward, then moves backward. So again it covers 2 meter. Then it again covers 2 meter. Then it again covers 2 meter. Right? How much it is? 2 plus 2, 4 plus 2, 6 plus 2, 8. Right? Now it is said that the drunkard first moved the 5 steps forward. The drunkard is actually moving 5 steps forward. So here, now if the drunkard moves 5 steps forward, it covers the total distance of 13 meter, right? If the drunkard moves 5 steps forward, that means he is covering 5 meter, and in that case he is covering overall how much? 13 meter, and in that case he will fall in the pit. He is not able to come back, right? This drunkard is not able to come back now, this drunkard will fall into the pit. So how much distance it's covering? 13 meters. See, 2 plus 2 plus 2 plus 2 and plus 5. Now how much time it's taking? So 8 seconds for the first part, 8 seconds for the next part, 8 seconds, 8 seconds. How much it is? 32, right? It will be 32 seconds. But for this 5 meter, it takes 5 seconds. So the total time taken is 32 plus 5. Once you solve this part, you'll get this 37 seconds is the right answer. Okay. So your D option is absolutely right, which is 37 seconds. Vishal, is it okay? Okay. So if we talk about the types of the speed, actually for this we have the speed also. Okay. And speed is simply said that to be the distance traveled by the person per unit time. Okay, it's nothing but the simple formula we have, distance upon time. And for the NEET exam, you have to just remember this formula. Okay, it's a scalar quantity having the SI unit as the meter per second, CTS unit as the centimeter per second, and the dimension as m0, LT minus 1. See, in order to measure the speed, we have a device called the speedometer, and you have seen the speedometer also in your bike and scooty, whatever you have. Okay. So now if we talk about the types of the speed, so we have 4 different types of speed: average speed, instantaneous speed, non-uniform speed, and the uniform speed. अगर हम बात करें average speed की, so average speed is something like that how much is your speed in the total journey. Suppose if I'm moving from one place to the another, suppose I'm in Kota, and from the Kota I have to move to the Delhi, right? So during that journey, there might be possible कि मैं 80 km/h की स्पीड से भी चलाऊं. There might be possible that I'm at a speed of 100 km/h, and there might be possible I'm moving with a speed of 20 km/h also. So in that complete journey, how much is the speed? For that, I must say that how much distance is covering from Kota to distance. How much distance I'm covering from this Kota to distance? Suppose the distance I'm covering is S. So how much time I'm taking? Suppose I'm taking the time delta t, which is the time interval. Okay, just remember this thing. We always take the time interval because whenever you are at Kota, you have some different time. When you are at Delhi, you have some different time. So in that case, you have the time interval, not the exact time. So just make this thing very much clear that you have to use the time interval. So the distance traveled by you is S and the time interval is delta t. So in that case, the average speed can be written as total distance upon total time interval which we have, right? Okay, so now the second thing which we have is the instantaneous speed. And if we talk about the instantaneous speed, what is actually the instantaneous speed? क्या होती है ये instantaneous speed? This is actually the speed at some particular instant. किसी भी particular instant पे speed कितनी होगी? See, something like when I was moving from when I was going from Kota to Delhi, what will be my speed when I reach Jaipur? Maybe some fixed value we have, right? So this is actually the instantaneous speed, that the fixed value of the speed at particular instant. So for this you want instantaneous, right? Particular instant you want. So for that you have to make this time interval very small. Okay, instantaneous speed के लिए आपको time interval को बहुत छोटा करना पड़ेगा. For that you have to shrink it. Okay, so for that what we say that the time interval delta t should be 0. Okay, so in that case the instantaneous speed can be written as limit delta t tends to 0 s by delta t. Okay, now for this the v instantaneous speed can be simply written as ds by dt, or it simply means if you have the value of the distance in terms of the time, then you can simply differentiate it and get the value of the instantaneous speed. Okay, now if we talk about, so see, for the instantaneous speed we have our device like that speedometer. Actually the speedometer is giving us the instantaneous speed. Okay, this speedometer which we have here, this speedometer is actually giving us the instantaneous speed. You're getting this? Okay, let's move ahead and let's talk about the non-uniform speed. So it's simply the thing that if you are covering the unequal distances in the equal time interval, like in the first 1 hour I'm covering 100 kilometers, in the next 1 hour I'm covering 200 kilometers, and in the next I'm covering 500 kilometers. So my speed is not constant actually, right? So this is the non-uniform speed when I'm not having the constant speed. Okay, so this is your non-uniform speed. So for that I must say that it is what, when we cover unequal distances in equal time interval, right? And if you talk about the uniform speed, so it simply means that it's the constant speed when you cover the equal distance in the equal time interval. पहले एक आवर में आपने कवर किया 100 किलोमीटर, in the next 2 hours, in the next 1 hour you will cover again the 100 kilometers, in the next again 1 hour you will cover the same 100 kilometers. This is the case of uniform speed when you have the constant speed. Remember? Yeah, very good. So if we talk about the question, so we have a question here that the particle moves from A to B such that, see, इस क्वेश्चन में A से लेके हम B तक मूव कर रहे हैं और यहाँ पे ये जो मोशन हो रहा है इसके लिए जो डिस्टेंस है, you can say that is the distance is given as a function of the time. X जो है वो टाइम का फंक्शन दे रखा है. The average speed in the interval t equals to 0 to t equals to 1 second is, in that case you have to tell me the average speed. Okay, so average speed के लिए मैंने क्या कहा, average speed is total distance traveled. It's total distance traveled upon total time, right? Now, okay, how will you find this total distance? How you will find this total distance?
Right.
For this, what I'm doing, you see. For this, what I have to do is at this point, at point A, suppose this is my initial position. I am at t equals to 0 at point A. So just put this value of t equals to 0 in this equation of x. So you will get the value at point A as 0. If you put the t equals to 1, in this equation, what you will get? 8 minus 3, it comes out be 5 meter. Okay, so this will be your 0 and this will be your final 5 meters. So this is actually the original point. Okay, so you are starting from this and you are moving to this, and while moving from A to B you cover a distance of 5 meters. So total distance you covering is 5 upon total time. How much time you are taking? Time interval 1 minus 0, it's simply 1. So 5 by 1 is the 5 meter per second. You have the final average speed as 5 meter per second, which is in your option number A. Okay.
Okay, sir.
Thank you very much.